Hi guys, in today's video we're going to have a look at Probability and Statistics paper 52 from October-November 2022 series. Before we start with the first question, just a small disclaimer. At this point there is no mark scheme available yet for this paper, so I might make a couple of mistakes along the way, and if you spot any, please let me know in the comments to this video, because that will help a lot to other students who are watching this video. And with that being said, let's have a look at the first question. So that question is about probability, and to make it easier to understand, I will start by drawing a probability tree diagram. So the guy can travel either by bus, or by car, or by foot. And in any case, he can be either late or not late. Now let's put the probabilities on our tree diagram. So the bus is 0.2, the car is 0.1, and on foot 0.7. The probability to be late if he travels by bus is x. So not late will be 1 minus x. He's late if he travels by car with 2x. So 1 minus 2x if he's not late. And last but not least, he's late if he travels by foot, where the probability is 0.55. So that means the probability of him not being late in that case is going to be 0.75. Now we're given that on any randomly chosen day, the guy is late with the probability 0.235. So that can happen in three scenarios. So first, he can go by bus and be late. Second, he can go by car and be late. And third, he can go by foot and be late again. And to find that probability, we'll have to multiply 0.2 by x, then add 0.1 times 2x, and then plus 0.7 times 0.25, and the result should be equal to 0.235. Now simplify that, and we'll get 0.4 x plus 0.175 equals to 0.235. Now move all the numbers to the right side, and 0.4x equals to 0.06. And finally divide both sides by 0.4, and we'll get x equals to 0.15. I will keep this as the answer for my first question. Next question is about conditional probability, and we'll have to find the probability that he travels to school by car, given that he is not late. And for that, I will use Bayes' formula. So I will have to swap the probabilities, then multiply by the probability of the first event over the probability of the second event without any conditions. So now let's have a look at our tree diagram. And now we know that x equals to 0.15. Let's fill out the probabilities. So 1 minus x is going to be 0.85. 2x would be 0.3. That is 0.7. And the rest is already there. So the first term in the formula, the probability that he is not late, given that he is traveling by car, is here. So we got 0.7. Now we multiply it by the probability that he travels by car, which is 0.1. And now we'll have to divide it by the probability that he is not late without any conditions. And for that we can use the probability tree again. So 0.2 times 0.85 plus 0.1 times 0.7, and then plus 0.7 times 0.75. And when we calculate all of that, we'll get 14 over 153, which is 0.0915. Okay, next question is about normal distribution, and we're given that the mean equals to 55.6. standard deviation sigma is 1.2. Altogether, we have 400 rods. And we're looking for the probability that our variable is less than 54.8. So the first step in those questions would be to standardize normal distribution. And for that, we're going to use the formula x minus mu over sigma. So 54.8 minus 55.6 over 1.2. So that brings us to z is less than minus 0.667. And a table for the normal distribution only gives us positive values. So we can swap it to 1 minus probability of z being less than positive 0.667. And if we search 0.667 in the table, we will get 0.7477. And finally, when we subtract, we get the answer. Okay, and question B, find the probability that our variable is within a half standard deviation of the mean. So it could be either within mu minus sigma over 2 or mu plus sigma over 2. And now let's calculate both values. Our sigma is 1.2, so that is 55, and mu plus sigma over 2, 55.6 plus 1.2 over 2, that is 56.2. And now again, we'll have to standardize our normal distribution. We're going to do x minus mu, 55.6, divided by sigma. And the same stuff here, 56.2 minus mu over sigma. And we'll get minus 0.5 and plus 0.5. So now, how do we find that? Think of the graph of the normal distribution. Let's say here we've got minus 0.5, and here it is positive 0.5, and we're looking for that area under the curve. Now remember, the table gives us the area to the left of a certain value. So we can take the area to the left of positive 0.5 and then subtract the area to the left of a negative 0.5. So the first one should be easy, and for the second one, we can just replace it with 1 minus the area to the left of positive 0.5. Now we open the brackets, and we get 2 probability of z being less than 0.5, and then minus 1. Now we can search the probability of z being less than 0.5 in the table for the normal distribution, and we'll get 0.6915 minus 1. Put this on a calculator, and we'll get 0.383. I would say that's going to be the answer. Okay, the next question is about 3 dice. And first of all, I want to find the total number of all possible outcomes. Now, when I combine independent events, I will have to multiply the number of the outcomes of each to get the total number of the outcomes. So when I roll the first dice, I can get 6 possible outcomes. And the same stuff happens when I roll the second and the third dice. So altogether, I will get 6 cubed or 216 outcomes. Now, how many of them will result in a score of 17 or more? Now, 17 can happen if we do 6 plus another 6 and 5. Or it could be 6, 5, and 6. Or it could be 5, 6, and 6. Now, more than 17 could be 18. And this can actually happen only in one way, that is 6 plus 6 plus 6. Now, altogether, we have 4 possible outcomes. So that means the probability to roll the score of 17 or more is going to be 4 over 216. And if it's simplified, we'll get 1 over 54. But that's not the final answer yet, because we're looking for the probability that this score appears exactly on the 6th throw. So what it means is that for the first 5 throws, we should not get 17 or more. And only on a roll number 6, we get 17 or more. So that means we're going to multiply 53 over 54, which is the probability to roll less than 17. That should happen 5 times in a row. And the last probability should be 17 or more. And when I calculate this, I will get 0.01687. And let's give it correct to 3 significant figures. 169. Okay, now for question B, we can either find it in a straightforward way, that means I will have to find 7 probabilities, or I can just subtract the probability of the opposite event from 1. That's what I'm going to do. So 1 minus the probability of the opposite event is going to be 53 over 54, and then to the power of 7. That's going to be equal to 0.1226. Okay, in question 4, I'll have to draw the histogram. And one thing to remember that I will have to draw a frequency density, which means I will have to take frequency of each interval and divide by the length of the interval. Length of the first interval is 20, the second also 20, this one is 10, 10 and 40. Now frequency density is going to be 32 divided by 20, which is 1.6. This one 46 divided by 20, 2.3. That one 96 divided by 10, 9.6, 5.2, and 0.6. Now first thing I have to do is to label the axis. This one is going to be time in minutes. And for y-axis, we're going to have frequency density. Now choose the scale, and I think the most appropriate one would be 1 square 1 unit for the frequency density, and 1 square is 10 units for the time. And I'll just draw those rectangles. Okay, here we go, that's the histogram. I believe everybody can draw rectangles, but a couple of things to remember. First, draw the frequency density on y-axis. Second, label the axis. Third, choose the linear scale on both axes. And finally, indicate some of your values on your axis. And now we can move on to the next one. Okay, for the next question, we'll have to estimate the standard deviation, knowing the estimate of the mean. So now the mean is going to be 43.2. And we'll have to estimate the standard deviation. Now, if you look at the formula sheet, there is actually a formula for the standard deviation. That is going to be the sum of x squared times the frequency over the sum of frequencies minus mean squared, and then take the square root. However, in our example, we don't really know the exact values of the variable because we're given the grouped data. And that's why it's going to be the estimate. So instead of using the actual values, I will use the midpoint of each interval. Now let me create a new table, time, and I will use the midpoint and frequency. So the midpoint of the first interval is going to be 10, frequency 32. Next midpoint is going to be 30, frequency 46, and so on and so forth. Okay, now we can use the formula 10 squared times 32 plus 30 squared times 46, and so on and so forth. Continue. Now, over the total frequency, which is 250, and now we'll have to subtract the mean squared. And don't forget to take the square root. All in all, after substituting this in a calculator, I got 18.258. Now let's round it to 3 significant figures and put in the answer. $18.3. Okay, question 5 is about coins. So we have 3 coins and 2 of them are biased. And to start with, I'm going to draw a tree diagram. And for that diagram, I'll use a blue color for biased coins and black color for fair coins. So first, let me start drawing the diagram from the biased coin. It can show either head or tail, which is not head. And the same happens for the second biased coin. Either head or not head, head, not head. Now the biased coin shows head with a probability of 1/4. So this one is a quarter. This one is 3/4. Now moving on to non-biased coin. Head or not head. And because it's not biased, then each probability is going to be 1/2. Okay, and question A is only concerned about biased coins. We have to show that the probability that at least one of the biased coins shows a head. I will calculate the probability of the opposite event and subtract it from 1. So I'm looking for the probability that none of the biased coins show a head. And it can happen only in one way. Not head and not head. So it's 3/4 times 3/4. And then subtract the result from 1. Which is 7/16. Okay, now the question is about the conditional probability. And for that, I will use the formula P of A intersected with B over P of B. Now, P of A intersected with B, so the probability of event A and B happening at the same time, it is going to be just using the tree diagram, 1/4 times 1/4 times 1/2, 1/32. And probability of B from the previous question is going to be 7/16. Now, all in all, we'll get 1/32 divided by 7/16. Now simplify, and we'll get 1/14. Okay, next question is about probability distribution table, and our variable is the number of heads we get when we throw 3 coins. So first of all, what values can x take? We can get either 0 heads or 1 head, 2 or 3. Now we'll have to calculate each probability. So for the first one, I have only one scenario. That equals to 9/32. Next, probability to get only one head. So that means either the first coin shows head, and the second and the third shows no head, so it's this way, or not head, head. Only 2 scenarios. The probability of the first scenario is going to be 1/4 times 3/4 times 1/2. That is 3/32. And then the second scenario, so 3/4 times 3/4 times 1/2. That's 9/32. And combine them together, that's 3/8. Now let's keep x equals to 2 and go into x equals to 3. So 3 heads can only happen in one way. It's 1/4 times 1/4 times 1/2. 1/32. And to find probability that x equals 2, I will subtract all other probabilities from 1. That is 5/16. Okay, done with this question. Next, we got binomial distribution. So the probability of success is 0.9. Now, altogether, we got 12 customers, so n equals to 12. And we're looking for the probability that fewer than 10 of those are connected immediately. So we're looking for the probability of k to be less than 10. Now, that can happen in many ways. K could be equals to 1, k is 2, 3, 4, 5, and so on. So it's way much easier to calculate the probability of the opposite event and subtract it from 1. So it's going to be 1 minus probability that k is bigger or equal than 10. And that can happen in 3 ways. K could be equal to 10, 11, or 12. And now let's use the formula for binomial probabilities. It is for the case where k equals to 10, 12c10 times the probability of success to the power of 10 times the probability of failure, 0.1 to the power of n minus k, which is 2. And continue, 12c11, 0.9 to the power of 11 times 0.1 to the power of 1, 12c12, 0.9 to the power of 12, 0.1 to the power of 0. Calculate each and add them up. I got 0.88913. and then subtract it from 1. I got 0.11087. Now let's round it to 3 significant figures. 0.111. There we go. Okay, now normal approximation to binomial distribution. Got a bigger sample, n equals to 80, and we have to find a probability that k is bigger than 69. And still, the probability of a single success is 0.9. Okay, let's get started. We're looking for the binomial probability when k is bigger than 69. And for that, we're going to use the normal approximation. And at this step, we have to make a continuity correction. So when we use the normal approximation, then that number is never going to stay the same. It is either going to be 0.5 bigger or smaller. So we'll have to use either 69.5 or 68.5. Now, our inequality sign is bigger, but 69 is not included. So that means I will use 69.5. And if 69 was included, I would have used 68.5. Now, at this step, we will have to standardize our normal distribution, and for that we need the mean and the standard deviation. Now, we can use binomial distribution to calculate those. Now, those formulas are given in the formula sheet. So mu is going to be n times p. So 80 times the probability of success, 0.9, that is 72. And sigma, actually sigma squared, is going to be n p times 1 minus p. So it is 80 times 0.9 times 0.1. That is 7.2. Now we're ready to standardize. Now we're going to use z bigger x minus mu over sigma. Don't forget to take the square root. Calculate this and we'll get minus 0.932. Now we have to remember that the table for the normal distribution shows us the probability of z being less than some positive value. So we'll have to change our probability into 1 minus p of z being less than a positive 0.932. And when I searched for the probability of z being less than 0.932 in the table, I found that is 0.8243. So all in all, I got 0.1757. Let's round it to 3 significant figures. So that. Okay, next one, we'll have to justify the use of our normal approximation. Now the key is that our binomial distribution should be relatively symmetrical. And that happens if n times p is bigger than 5 and n times 1 minus p is also bigger than 5. So now all we have to do is to calculate both values. And p is going to be 80 times 0.9. That's 72 and it's bigger than 5. So okay. Now n times 1 minus p is going to be 80 times 0.1, which is 8, and 8 is checked on that bigger than 5. So both conditions are satisfied. Okay, here we go, everybody's favorites, combinations and permutations. Right, the first one we have 9 letters, so I'm going to draw 9 spaces. Now, the two A's must be together, and the two L's must be together. And for this sort of questions, we have a technique, I call it mega objects. So I combine the two A's into one larger, I'll call it mega object, and the same goes for the two L's. Now we know that the number of ways to arrange n objects in a line is going to be n factorial. Now, how many objects are there together? 1, 2, 3, 4, 5. We count a mega object as 1, so 6 and 7. So altogether, there's going to be 7 factorial. And now, if the letters inside those mega objects were different, I would have to multiply by the number of ways to rearrange those letters. So that would have been times 2 factorial if the letters were different. But they are identical. So there's no need to multiply. And there we go. 5040 is the answer. All right, next question. How does should be R? All right, find the probability that the two L's are together and there are exactly 6 letters between the two A's. Now, because we're looking for the probability, I will first find the total number of all arrangements. So we have 9 letters in total. That brings us to 9 factorial. And now we have 2 identical L's, so divided by 2 factorial. And we also have 2 identical A's, another 2 factorial. And that is 90,720. Now here comes the more difficult part. 2 L's are together, and 6 letters, exactly 6 between the 2 A's. Now, how can this happen? Let's draw the diagram again. I need to have 6 letters in between A's. So let's put the first A here, so the second one must be right there. And now, because there should be exactly 6 letters in between, I can move those letters one space. So that's the other scenario. And because we have to have exactly 6 letters between A's, I don't see any other scenario. Next, the 2 L's must be together. And because of the way how our arrangement looks like, we can see that the 2 L's must be in between those A's. Now let me write the word separately. Now, the 2 A's are gone. And the 2 L's are also gone. And we don't have any identical letters anymore. Now, looking at the first scenario, how many ways are there to fill up this position? We got 5 ways to do so. Now, looking at the space between the 2 A's, we'll realize that we actually have 1, 2, 3, 4, 5 objects. And the number of the ways we can rearrange them is going to be 5 factorial. So all in all, we got 5 factorial times 5. And absolutely the same stuff happens here. We have 1, 2, 3, 4, 5 objects in between those 2 A's, and 5 ways to choose the first letter. So our result is going to be exactly the same. It's 5 factorial times 5. So all in all, we got 2 times 5 times 5 factorial. or it's going to be 1200. Now we're looking for the probability, so we'll have to divide 1200 by the number of total outcomes, which is 90,720. And that is 0.0132. And finally, the very last question. We're going to select 5 letters, and our selection must contain at least one A and at most one L. So let's carefully write down all possible scenarios. Let's say first we can have one A and one L. Or we could have one A and 0 L. Or we can have 2A, 1 L. Or we can have 2A and 0 L. Okay, now let's consider all these cases separately. For the first one, we got one A and one L, so those are chosen already. And we're not allowed to choose another L and another A. So we have 3 positions to fill, and 1, 2, 3, 4, 5 choices. So it's 5C3. For the next one, we got 1A. So 1A is gone. Now we're not allowed to choose one more A, and we shouldn't have any L's. So these are also not allowed to choose. So in that case, we have 4 positions to fill, and 1, 2, 3, 4, 5 choices. So it's 5C4. Okay, next one we have 2 A's and 1 L. That means 2 A's are chosen, and 1 L is chosen. We're not allowed to choose one more L. So we have to fill 2 places, and we have 5 choices. And in the last case, we have 2A, 0 L. So 2 A's are chosen. We cannot choose any of the L's. Therefore, we have 3 positions to fill, and again 5 choices. Now, add up all of that and get 35. I'm going to keep this as the final answer. Okay, and that was the final question of this paper. Now, once again, at this point, there is no mark scheme for this paper. So I could have made some mistakes, and again, if I made any mistakes, please let me know in the comments. Also, let's have a bit of a discussion about that paper. Do you think it was more difficult than other past papers, or do you think it was the same, or possibly it was easier? And I will see you next time. Bye bye.